So, good evening. My name is Dr. Selvan. I'm here in Dubai. About myself, very briefly, I hold a PhD in management, and I'm also a certified Six Sigma Black Belt from ASQ, American Society for Quality. And I also have several other certifications like PMP and CMQ and so on. So what is relevant to this webinar is the Six Sigma Black Belt, which I hold from ASQ, American Society for Quality. All right. So if you have any questions about the certification and the different levels of belt, keep it with you. At the end of the webinar, there is one slide where I will talk about different levels of Six Sigma belts, where I can able to answer some of your questions. Okay. All right. So before I start, I just would like to post a very simple question just for me to understand at what level of depth I need to do this webinar. So a quick poll, don't take more than 10-20 seconds and try to answer this, please. Okay, I'll give you 10 more seconds. All right, great. Let me end this poll. Okay, would you like to see the result? Let me share it with you, just if you like to see it. So how much do you know about Six Sigma? About 30% of you said nothing. Again, around 30% of you said have some vague idea and some knowledge. So I would assume that almost 96% of you have known nothing or some very basic knowledge or some vague idea. So I don't see anyone except about 6 people working on a Six Sigma project or worked on a Six Sigma project, and no one are declaring themselves as a Six Sigma expert. Okay, that's a good news for me. So you will not pose any challenging question. All right. Okay. So so now that I understood about the background, what I will do is I will slowly, start from the very basic and try to, build it up from there. Okay. So what we are going to discuss today, what is Six Sigma, the basics of Six Sigma, the very popular DMAC model, which stands for define, measure, analyze, improve, and control. We don't go deep into it. We're going to touch only one component of the DMAC, where we're going to talk about how to measure your process performance. And that's what we're going to discuss in this seminar in detail. So basically that comes under Six Sigma metrics, measurements. Okay. And I will leave about 20 minutes or so to answer your questions at the end of the webinar. All right. Okay. Now let's see again quickly, not spending much time, 20 seconds. Can you read this question and answer this question? And keep it in mind, please post all your question, not in the chat, because chat will have too many content. I will not go through it. Please type your question on the Q&A. There is another option. You can see Q&A. Please type your questions there. Someone is asking what's the difference between QMS and Six Sigma. It's a good question, but put it on the Q&A so I can answer them and everyone can read your question also. Okay, I'll give it 10 more seconds. All right, that's enough. Thank you. I got many, many responses. I'm going to end the poll. Well, the moment I said I'm going to end the poll, I got like more than 20 people responding. Okay, I'm going to end the poll now. Okay, would you like to see the result? Now here is the result. And so basically, when I ask you the first question, how much you know about Six Sigma, many of you said you are at the very beginning level. I know you have the vague idea. None of you said you are an expert, or very few have said you worked on a project. And it looks like what you said was the real truth. There is no lie behind it. That is something I can see from your answer to this question, right? Which of the following best describes the Six Sigma philosophy? The right answer to this question is the first choice. Okay, team working on short to medium term project that solve problems which directly affects the bottom line, using data to drive their decisions. So Six Sigma is a data-based, data-driven tool. Most of you have selected option 3, about 73 of you. Why it is not the right answer? This is also connected to one of the question a gentleman just asked. What is the difference between QMS, Quality Management System, and Six Sigma, where I said I will talk about it later, right? The key point here is, if you read the first line, it says a structured management approach for the entire organization. Now that is wrong. Six Sigma is not for the entire organization. Quality management system is for the entire organization, while Six Sigma is mainly for process. So it's a process by process approach. Okay. All right. I'm going to talk about it more. Yep. No worries. All right. Let's move on. Let's see here. Every company, right, or organization, even non-profit organization, even governments, must make money in some form or another to stay in business, isn't it? If an organization spends more than it takes in, meaning it spends more than its income, then it will be obviously out of business. Thus, the challenge for every organization is to become profitable, okay, at whatever it does, so that it can continue to do what it does. So the key here is profitability. Okay, now profitability, you know the formula for profitability, right? Income minus expense, isn't it? Equals to, if the value is positive, it's a profit. If the value is negative, it is a loss. So what Six Sigma can help you to do is, it can possibly increase your income and it can decrease your expense. Even if you keep this income constant, because the expense is going down, the profit is going to increase generally, isn't it? So Six Sigma hits the bottom line of your organization, that is profit. Now, how is it going to do it is what we are going to study in this webinar. So Six Sigma is a structured and disciplined process-based approach. Okay, what am I structured and disciplined? Structured and disciplined means there is a model available to implement Six Sigma. Any Six Sigma project you take, it follows the model of DMAC. Okay, so that's what we meant by it follows a structured and disciplined approach. Okay, so define, measure, analyze, improve, and control pretty much follows the principle of PDCA, which I think most of you or all of you must be aware of. So there's a particular model, a systematic process you follow to implement the Six Sigma project to bring improvement to your bottom line. Okay, it aims to improve the bottom line by finding and eliminating the causes of mistakes and defects in the business processes. Right. So Six Sigma is going to help you to find the root cause of the defects of the mistakes, and it's going to fix it in your business processes. All right, let's come to the fundamental question. What is Six Sigma? As in literally, what is six and what is sigma? Now, six is a six. We all know 1, 2, 3, 4, 5, 6. Now, what is sigma means? Sigma is a statistical term that refers to the standard deviation. Okay, some of you or most of you must know what is standard deviation. Standard deviation is a statistical measure, okay, of variation. Okay, so what standard deviation does is it measures the variation in the data set. And we all know in business, variation is not a good thing, isn't it? Variation will cause business to suffer. We would like to hit the target. We would like to achieve what we intend to achieve, and we don't want variations. But we know variations are part of any process we perform. But what we try to do here is we try to minimize the variation. The variation is minimized in such a level where the variation does not exceed 6 standard deviation away from the mean. In other words, you minimize the variation in such a way that in a Six Sigma process, the possibility of you producing a product or service beyond the acceptable limit is not more than 3.4 per million opportunity, right? So those are all the calculations which we are going to do today. Okay. Six Sigma is a metric, okay, where it corresponds to 3.4 defects per million opportunity. Okay, don't worry about it because there are many key topics here. For example, what is defects? What is opportunity? We know what is a million means, right? So we're going to discuss about these things later in detail. I'm just talking about what is Six Sigma. And it also accounts for 1.5 sigma shift. Okay, actually speaking, when you achieve Six Sigma, you produce only 2 defects per billion. When you achieve Six Sigma, you produce not more than 2 defects per billion. Extreme level of perfection. But we know over a period of time, our process capability will decline due to a lot of reasons. It is safer to assume that 1.5 sigma over a period of time we will lose, right? So what quality gurus are saying is, even though we are achieving Six Sigma, let's say that we have achieved only 4.5 sigma, but they don't use the term 4.5 sigma. They will say 3.4 defects per million opportunity, right? So 3.4 defects per million opportunity corresponds to 4.5 sigma. But we don't say 4.5, we say 6, because what in reality we are doing is we are achieving this, but we are disclosing this. Okay, so maximum is 3.4 defects per million opportunity when you're achieving Six Sigma. But in reality, you might be doing only 1 defect per billion or 2 defects per billion or even 0 defects per billion. Okay. All right. So I'm going to talk about this DMAC a little later. Okay. So a while back I said, okay, someone asked the question, what's the difference between QMS and Six Sigma? Now, QMS is a quality management system. Quality management system. Okay. Can someone tell me what is a system in a chat box? We know what is quality, what is management, what is a system? Yes. System is a set of processes. Okay. System is nothing but a collection of processes. Exactly. So when we use the term quality management system, it's for the entire organization which uses set of processes. But when we use Six Sigma, it is for a process. We are going to improve a process to a Six Sigma efficiency. So any process you take, okay. So any process you take, what will happen? It will have inputs and it transforms the input into output, isn't it? So any process you take, it will have inputs, it will have outputs. This is the output, okay? We try to achieve Six Sigma capability, all right? So the equation of y equals to function of x, where y is the output and x's are the inputs. And that's what this equation is, okay? So any process you take, it requires inputs and it produces output. So what we are going to do in a Six Sigma project is we are going to control that process in such a way that the output is achieving our target and it's not deviating, it's not going outside the specification, not more than 3.4 defects per million opportunity. All right. Six Sigma uses a lot of tools during these 5 stages, during the define, measure, analyze, improve, and control. It uses many tools and techniques. This slide just gives an idea of what is the purpose of each stages, and what are the primary tools we use in each stage of the Six Sigma, and what are the key outputs we will get in each stage of the Six Sigma, right? What we are going to discuss today in today's class is we are going to specifically talk about this one, process capabilities. Okay, we're going to discuss about what is the capability of our process, what is the current capability of our process. Okay, let me give an example. Okay, for you to understand simply. Just imagine DMAC. Just imagine DMAC, like you're trying to lose weight. You try to lose weight. Okay. All right. So what you will mention in the define? What you will mention in the define? Your goal. What you would like to achieve. Okay. What is the goal you're trying to achieve? How much weight you want to lose? Right. Then what you will do? Measure. In measure, what you will do? You study the current weight. What are you currently? Okay. Then you analyze why you are overweight. Then you will try to make improvements, whatever it is, dieting, exercise, and so on. Then you try to control it. Okay. So measure is a very, very important stage or phase, because in measure, we try to understand what is our current capability? What is our baseline? Where are we standing now? Only then, when you make the improvement, we know that certain improvements has been made. Okay. All right. So these are the two things we're going to discuss now: Six Sigma metrics and process capability analysis. Right. Okay. Now someone might ask you, give some examples of a process. What do you mean by process? Now in this slide, you will see, right, there are so many examples given for the different types of processes. All right. Now somebody is asking, sir, no reply for my question yet. Now keep it in mind, put all your questions not in the chat. Keep all your questions on the question and answer, right? And if you have joined late, right, please know that the Q&A session will be at the end of the webinar. So any questions you have, just post it on the Q&A. After I finish my presentation, I will go to the Q&A and start answering all the questions. All right. Okay. All right. So these are all some of the examples of processes. Opening an account is a process. Distributing mail is a process. Issuing purchase order is a process. Paving road is a process. Refining oil is a process. So these are all examples of different types of processes a business performs, whether it's a manufacturing company or a bank or an insurance company or a healthcare facilities. Everywhere Six Sigma can be applied. Anywhere there is a process, we can able to apply Six Sigma. All right. So in any process improvement endeavor, the ultimate objective is basically how we can perform the process better. Okay. How we can perform the process faster and how we can perform the process cheaper. Right. So to answer the question of how we can perform the process better, we have certain measurements available, such as DPU, DPMO, RTY, which we are going to calculate. How we can perform the process faster? We're talking about cycle time, the amount of time it takes to complete a process. The next one is how we can able to perform the process cheaper. Here we're talking about how we can reduce the defects, how we can reduce the rework, how we can reduce the, the cost of poor quality. Okay, so you can able to perform the process better, faster, and cheaper. Okay. Any Six Sigma project you take, it generally falls under any one of them or any combination of these metrics or goals. Right. So DMAC, it stands for define, measure, analyze, improve, and control. In define, we will define the business opportunity. What is our goal? What we're trying to achieve. In measure, we try to understand our current state. Where are we now? In analyze, we try to determine the root cause of the problem. And in improve, we try to eliminate waste, variations, defects, repairs, reworks, and so on. And control, we try to sustain the result. Okay. Even when you achieve Six Sigma, remember what I said, in the control, it is okay to drift up to 1.5, because even when you achieve Six Sigma, I'm only disclosing 4.5, which is 3.4 defects per million opportunity. Okay. Now, Six Sigma is a letter for the Greek alphabet. Now, look at here. Okay, I think some of you or many of you knows what is a normal distribution. I will not be going deep into statistics. Okay, now if you notice here, okay, let me give an example. This line is your, assuming this is your target. Okay, so which one is better, narrow variation or wide variation? Which one is better for business? Narrow, isn't it? So narrow is better. Wider is a problem. Okay, wider means you have more variation from the mean. Okay, from the mean, which is your average. Okay, so wider variation is a problem. Narrow variation is good. What we try to do in Six Sigma is we try to achieve the narrow variation, right? Try to bring the variation as close as possible to your process average, to your target value. Okay, all right. So what happens when you go away? For example, right in the middle is your process average. Okay, ideally it should be your target. Okay, so when your variation goes 1 sigma to the left and 1 sigma to the right, okay, the total value which comes under it is 68%. Okay, in other words, 68% of the time your values falls between these two. Okay, minus 1 sigma to plus 1 sigma. I'll talk about this in more detail a bit later. Now it might be a little difficult for you to comprehend. Okay, then it is 2 sigma, then it is 3 sigma. Sometimes 3 sigma itself is very good, because if you notice here, 3 sigma is 99.73% conformance, only 0.3% non-conformance. Yeah, but in certain industries, certain businesses, certain processes, it is not acceptable. We need to achieve 6 sigma. All right, more about this bit later, not now. Okay, again, not now, bit later. All right, let's get into the calculations now. Okay, so in Six Sigma, we have many metrics. All right, now before I get into these formulas, let me quickly ask you a question. Okay, because you need to understand this fundamental when we talk about data. Okay, because remember, Six Sigma is a data driven approach. All right, so when we talk about data can be broken down into 2 types of data. One is called attribute data, other one is called variable data. Okay, so we have attribute data and variable data. So you need to know what is the difference between these two. What is an attribute and what is a variable data? Let me ask you a question. For example, how many participants in this webinar right now? Okay, is it an attribute data or variable data? Type it in the chat box. How many students, how many participants right now? Is it attribute or variable? Okay, good. All right. Let me ask another question. Let me ask you another question. If I ask you, okay, if I ask you to go out to your balcony or to the street and check how many people are crossing your road for the next 1 hour. If you have to go out and see how many people are crossing the road for the next 1 hour. So is it attribute or variable? All right. Now, here is the answer. For both the scenarios, the answer is attribute. Okay. None of them is variable. All right. Okay. First one. When I ask you how many participants right now in this webinar, what was my question? What was my question? How many? Which means what you're going to do, you're going to count, right? You're going to count. If you count, it is attribute. My next scenario, what I said, go out and check, see how many people are walking on your street or crossing your street for the next 1 hour. Again, what you're doing, you are counting. When you're counting, it's attribute data. Okay. When you are measuring, it's variable data. What are the things you measure? Okay. For example, height, weight, diameter, distance, mass, right? Those are all things we measure. Temperature we measure, where the value could be in decimal places. Okay, 41.33 centimeter or millimeter, or 41.33 grams or milliliter, right? That is the variable data. So attribute data we can count, variable data we measure. Okay. Now why I'm saying this is because most of what I'm going to explain here, okay, is for attribute data, which means we are going to count. Yeah. What are we going to count? What are we going to count? Here is the word. What are we going to count? We are going to count the defects. Okay, we are going to count the defects. Yes, very good. Now, then that begs the question of what is the difference between defects and defective? Okay, what is the difference between defects and defective? Right? Now, defect means, let's take a product. For example, yeah, non-adjective. Okay. For example, let's take a product. Let's take a piece of, let's say, a furniture, a table. Let's take a furniture. Let's take a table. Okay. Now, this table might have several defects. For example, the legs are not straight. Okay. The surface is not smooth. Yeah. The screw are not tightened properly, or there is a crack on the leg, or on the table top, there is a color, discoloration. These are all defects, meaning a table can have, for example, 10 defects. Understand? A table can have 10 defects, right? Now, what is defective? The moment the table have a defect, whether it is one defect or two defect or three defect, the table becomes defective. In other words, when we use the term defective, okay, we will count simply, is the product defective, yes or no. The outcome is either yes or no. Okay. While defect means we can start counting them. For example, this product have 8 defects, or this product have 3 defects, or this product have 1 defect, this product have 0 defect. Okay. Now for a product to not to be defective, it should be ideally have 0 defects. Okay. Is it clear? Do you understand what I just said now? Okay. So a product can have n number of defects. Okay. 1, 2, 3, 4 to the n. Right. Okay. Defective means the moment it has a defect, the product becomes defective. Okay. Naturally, some defectives are very severe comparing to other defectives. That depends on the type of defect. Okay. All right. Now everything what we're going to discuss here, if you notice, everything what we're going to discuss here, if you notice, right, all of them are defects. It doesn't talk about defectives. Now, why we don't talk about defectives? Can someone tell me why we are not talking about defectives, but we talk about defects? Why we don't talk about defectives, but defects? Because defective will not give a clear picture. Defective will not give a clear picture. Why? For example, let me give an example. Okay, let me clear this screen. Hold on. Yes. Okay. Like Mr. Muhammad said, because we don't know the number of defects. Yes. For example, I have two tables, table A, table B. Table A has 4 defects. Table B has 1 defect. Now, both of them are defective. But which one is more severe in defective? A, isn't it? So this information is hidden when we use the term defective, and that is why it is always better to use the term defects instead of the term defective. Got it? because the cost to fix one defect comparing to the cost to fix 4 defects, obviously there will be big difference, isn't it? So that's why we always talk about defects, not defectives. All right, great. Now let's go through one by one. Okay, let's quickly look at this slide. Okay, how good is Six Sigma? If you notice here, if you're operating at 3 sigma, okay, sorry, if you're operating at 3 sigma, fine, you're good enough, but still look at here, cost of poor quality is 20 to 30% of your revenue. 20 to 30% of your revenue can get into unnecessary expenses. We call it as hidden factories: reworks, repairs, service calls, warranties, guarantees. Those kind of things will happen. Yeah. So when you achieve Six Sigma, we're talking about world class, right? So 3.4 DPMO, yield is 99.9997, and your cost of poor quality is definitely less than 10%. Exactly what it is, we don't know, but definitely less than 10%, which is very good, isn't it? Comparing to 20% of cost of poor quality, less than 10 is huge. That's a 10% reduction. Now, when your company income or the expense runs into millions, imagine a 10% reduction could be a huge impact on your business. Okay. All right, let's look at the first formula. The first formula is called throughput yield. Okay, throughput yield. It is in acronym. It is not TPY, but it is YTP. Yeah, throughput yield. Okay, so what is a throughput yield? How do we calculate it? Okay, what is a throughput yield? How do we calculate it? For example, you have a 3-step process for producing labels. Yeah, labels, like a label. Okay, the labels are first printed in a machine, then laminated, and then cut. So it's a 3-step process. You want to calculate throughput yield at each step of a process. Okay, again, this process has 3 steps. Step 1 is printing, step 2 is lamination, step 3 is cutting it, which means each of this step will have input and output. For example, for printing, the input could be plain paper, the output would be printed. Okay, for lamination, it will be printed paper, then output will be laminated and printed paper. Then the input for cutting is a laminated printed paper, and the output will be labels cut it into pieces. Okay. All right. Now you want to calculate the throughput yield, okay, at each step of the process to know the overall throughput. Okay, that is called rolled throughput, which is the next slide. But here let's talk about it. For example, 1,000 labels go into the printing process. 950 of them are printed labels are acceptable. The rest 50, some printing issues, some errors, which means your throughput yield for step 1 is 95%. Got it? Okay. Then 950 label only goes to the next step, lamination, right? Of which 800 comes out properly. So the throughput yield is 84%, basically 800 over 950. Yep. Third step is 800 label, which is output of the second step, goes to the cutting process, and 700 comes out. So the throughput yield is 88%. So 700 over 800. Okay, 88%. Right? Now, that is the throughput yield for each step in a process. But what we are interested to know is the throughput for the entire process, isn't it? Because one by one doesn't give us any good idea. We want to know the entire process. And that is why it is called rolled throughput yield, which is basically multiplication. Okay, multiplication of the each step throughput rate, then you'll get the final throughput. That is called rolled throughput yield. Okay, which is 0.95 times 0.84 times 0.88. Okay, can someone use the calculator and check if this value is correct? Use your calculator and check if the value is correct. Yes. Okay. Yeah. So 30% is non-conformance. Yeah, damages or non-conformance, or you have to repair it, or you have to scrap it, and so on. So your throughput throughput yield is 0.70. Right. So that's how you calculate throughput yield and rolled throughput yield. Okay. All right. Now let's now calculate DPU, DPO, and DPMO, which is a good, interesting one. First one is called DPU, which stands for defects per unit. Next thing is called DPO, which stands for defects per opportunity. That's a very interesting term, which we'll talk about it. Next one is DPMO, which stands for defects per million opportunity. Okay, defects per million opportunity. Let's go through one by one. The first one is DPU, which stands for defects per unit. So we need to know how many defects we are making per unit. Okay, per unit of production, per unit of output, what is the number of defects we are making? Okay, all right, let's look at this scenario. Okay, example of calculating DPU. Your printing business prints custom stationery orders. Each order is considered a unit. Okay, each order is considered a unit. 50 orders are randomly selected and inspected, and the following defects are found. 2 orders are incomplete. Okay, 2 orders are incomplete. 1 order is both damaged and incorrect, which means this particular order has 2 defects. And 3 orders have typos. Okay, typing errors. So totally how many defects you have? 2 orders are incomplete, 2 defects. 1 order is both damaged and incorrect. That's 2, because you got 2 defects. 3 orders have typos. So 3 orders have typos. So 3 typos, 2 damages and incorrect. And so totally you have 7 defects. Out of how many? Out of how many orders? 50 orders. Okay. In this case, each order is 1 unit we are considering. Okay. This could be 50 tables, 50 whatever. Okay. All right. So what is your DPU? Your DPU will be 7 over 50, because there are totally 7 defects from 50 units. So your DPU, defect per unit, is 0.14. Okay, 0.14. Yeah, easy. All right. Now here look at this. Look at this interesting formula. Look at this interesting formula. Okay, if you know the DPU, we can estimate the RTY. If you know the DPU, okay, we can estimate the rolled throughput yield. We can estimate the yield. What is the formula for it? E, okay, base log to the power of minus DPU. So in your calculator, okay, you have to put E to the power of minus. So in this case, E to the power of minus 0.14. Okay. All right. This will give us the rolled throughput yield. So there is another way to calculate the RTY. All right. Okay. So what I'm going to do now is, before I go to the next question, I'm going to post one question on the poll, and I would like you to answer. Read the question carefully and answer. I will give you 1 minute. Okay. Someone is asking what is the e log value, the natural algorithm, which is like 2.718. Usually you will have it in the calculator. That's a natural algorithm. All right. So what's the answer? Let me end the poll so you can check the results. Can you able to see the results? Hold on, let me share. Yeah. Can you able to see the result? Yep. So the answer is, like most of you have calculated, 0.18 is the answer. Okay. So it's 50 shirts and just count and do it. That's it. 2 plus 3 plus 1 plus 3 divided by 50. Okay. All right. Let me close it and come back. All right. This is the interesting one. Watch this one carefully, because the DPMO, the key Six Sigma metric, is based on this. What we saw here was DPU, defects per units. What we're going to see here is called defects per opportunity. Okay. What is defects per opportunity? Defects per opportunity is the number of defects in a sample divided by total number of defect opportunities, right? Number of defects in a sample divided by total number of defect opportunities. Okay, so watch this. Hold on. Each custom stationery order could have, each custom stationery order could have 4 defects, which means when you process an unit of customer stationery order, there is a possibility of you making 4 defects. What are the possibilities of you making defects? Okay, incorrect, typo, damaged, or incomplete. When you receive one order, there is a possibility of making 4 defects. When you receive one order, or when you produce one unit of whatever you're producing, there is a possibility of making 4 defects. Okay, so the total opportunity of producing one order or one unit is 4 defects. You have an opportunity to make 4 defects. Understand? Now, okay, so therefore each order has 4 opportunities. Now 50 orders are randomly selected, which means you have selected 50 orders. Okay. Now, can someone tell me in the chat, if you process 50 order, what is the total opportunities of making defects? How many defects? Exactly 200. By completing this 5 order, you have an opportunity of 200 defects you can make, assuming you're making each item for all the 4 defects. Okay, completely bad. Yeah. So there is a opportunity of making 200 defects. Got it? Okay. But how many defects you produced? 2 orders are incomplete. 1 order is both damaged and incorrect. 3 orders have typos. Okay. Same situation like before. Same scenario. Same number of units. But before we did not consider the opportunities of defect. We simply took the number of defect, which is 70, and we divided with the total number of units. But here what we are doing, watch carefully. We are taking 7 defects, and we are dividing this with total opportunity from this 50 orders. So we are not dividing with 50, but we are dividing with the 200. Okay. So our DPO, defect per opportunity, the number of defects you are producing for each opportunity is 0.035. 0.035. Okay, is it clear what I'm just explaining now? Okay, now then let me ask you a question. See how many of you can answer me. Let's take an airport. Let's take an airport. Okay, and in an airport there are many processes. Let's take a baggage process. Okay, let's take a baggage process. All right, let's assume each time when the airport is processing air baggage, one baggage, okay? Let's say, what are the issues? What could be the possible issues when the airport is processing your baggage? Lost baggage, damaged, theft, likewise. Okay, let's assume each time when the airport is processing air baggage from the flight to the conveyor, okay, there is a possibility of 5 defects. Each bag has a possibility of 5 defects. Okay, so the number of opportunity per bag is 5. Okay, now here is my question. To reach 1 million opportunity, how many bags the airport is has to process? Exactly. Okay, exactly. Now understand this concept very carefully. Very simple concept, which means when the airport is processing 200,000 bags, okay, the number of opportunities present is 1 million defect opportunity, right? Of which, when you achieve 6 sigma, you are saying not more than 3.4 defects per million opportunity. Not more than 3.4 defects per million opportunity. Now, what I'm trying to say now, understand carefully, because this is a confusion. A lot of people get confused. Because when we use the term 3.4 defects per million opportunity in the airport example, some people think, okay, 3.4, if an airport baggage process have achieved 6 sigma, it means some people think out of a million bag they process, not more than 3.4 bags will be defective or defect. Is it correct? Is that thinking is correct? Out of a million bag the airport is processing, not more than 3.4 defects will be present. It is wrong, isn't it? So the DPMO is not, look at the last word. It's not unit. It's not a 1 million unit you are processing. It is 1 million opportunities you are processing. Depending on what unit you're processing, if one unit have 10 opportunity, then by processing 100,000 unit, you reach 1 million opportunity. If a unit has 5 opportunity, like in this case, by processing 200,000 unit, you reach 1 million opportunity. Understood? Okay. So it's not 1 million bags or 1 million units. It is opportunities. If a unit has 10 opportunity, we're talking about 100,000. Okay. Because keep in mind, what we are counting is defects, not defectives. It's not, keep in mind, it's not 3.4 bags that are defective, right? It is 3.4 defects found in 200,000 bags, which means, for example, if one bag has all the 5 defects, okay, it came late, it got lost, or it got damaged, everything happened in a single bag. Even though it is only 1 unit of bag, you are not achieving 6 sigma, because 6 sigma means maximum you can go is 3.4. You have reached 5 defects in a single unit. Understood? Okay, somebody is asking, okay, few of you are asking to repeat again. Let me repeat. All right, let me repeat. Hold on. Hold on. Okay, watch this. When an airport is processing one baggage, there is a possibility of 5 defects. Okay, 5 defects include lost baggage, or late, or damaged, or items stolen, okay, or it went to the wrong carousel. Right? So when an airport is processing one bag, there is a possibility of making 5 defects. Understood? So how many bags an airport should process to reach a possibility of 1 million defect divided by 5? So 200,000. So when an airport is processing 200,000 bags, there is 1 million opportunities available. Okay, there is a 1 million opportunity possible. Got it? So when you say I achieved 6 sigma, what are we saying? The maximum number of defect is not more than 3.4 defects per million opportunity. 3.4 per million opportunity. Okay, per million is per million. Okay, maximum number of defects allowed per million is 3.4. Now in our baggage example, to reach 1 million opportunity, the number of baggage you have to process is 200,000. Okay, so out of the 200,000 baggage the airport is processing, not more than 3.4 defects should be there. Okay, which means it is very difficult, because if one bag has 4 defects, for example, it came late, it got damaged, some items are stolen, and it went into the wrong carousel, which means one bag have achieved 4 defects, which means straight away, just because of this one bag, you could not able to achieve 6 sigma. Okay, understood? So what I was saying is, some people or many people have this wrong consumption that 3.4 defects per million units. That is wrong. Okay, 3.4 defects per million units. It's not number of units, it's number of opportunity. Okay, so when you say 3.4 defects per million opportunity, it is not 3.4 bags, okay, got defects. It is not 3.4 bags got defect. One bag can have 1 defect, 2 defect, 3 defect, 4 defect. Understood? Okay, guys? Okay. Now, let's see if we can answer this question. All right, can I close it? End poll. Want me to share the result? Here is the result. Okay. So watch this. Only 50% of you got it right. I'm wondering what happened here. See here. The following information reflects data from a single operation in your process, right? Number of defects found 120. That is the number of defect, right? Yeah. So write it down, 120. Okay. Straight away 120. Okay. Divided by how many units have you produced? 9,600 units you produced. And each unit have 6 opportunities, 6 defect opportunities. So the formula is pretty simple. Yeah. 120 divided by 9,600 multiplied by 6. Number of defects divided by total number of opportunity. Okay. That should give you 0.0021. That is given here, you see. Okay, moving on. All right, now this is very simple. This is defects per million opportunity. Now, since we already know what number of defects we are making per opportunity, finding per million opportunity is very simple. All you have to do is just multiply by 1 million. Getting my point? So DPO is calculating defect per opportunity, per million opportunity multiplied by 1 million. Okay. See if you can answer this now. Same question, but instead of asking DPO, it is asking DPMO. Okay, can I end the? Don't do the chat. Please answer in the poll. Yeah, please, because we want everyone to try. Because if you directly type it on the chat, other people will not try. They just assume that is the right answer. Please. Okay. All right. Can I close it? This is a bit tricky one. Okay, I'm going to close it. Okay, let me share the result. All right, so many of you have selected 2100. Okay, and some of you selected 2083. Now, what is the right answer? Like sort of both of them are right, but to be precisely right, the answer is 2083, not 2100. See, in the previous poll, we round it off. Yeah, the actual answer is 0.00208, which we round it off to 0.0021. Okay, now here we're asking per million opportunity, which means you should not multiply the rounded off value, isn't it? You should take the actual value, which is 0.00283 in the calculator, multiply by 1 million. because when you're multiplying that with a million, or then you should not make a mistake of rounding it off, because there is a good amount of difference, right? There is a good amount of difference between 2083 and 2100. That's a 17 units, 17 defects. That's quite a lot of defects, isn't it? Especially when you're dealing with Six Sigma, where more than three defect will increase, goes less than Six Sigma. We should not use the rounding off here, isn't it? Yeah. Okay. Somebody's asking, write the formula. Okay. Write the formula. So the formula is number of defects divided by DPO multiplied by 1 million. DPO multiplied by 1 million. Okay, here it is written here. Watch this. Defects per million opportunity is the number of defects, okay, in a sample divided by, so number of defects divided by total number of defects opportunity multiplied by 1 million. So defect per opportunity multiplied by 1 million. How to find the DPO? DPO equals to total number of defects divided by total number of opportunities. Okay. All right. So what this mean? What it means, for example, let's look at this scenario. The one which is on the slide. Let's look at this one. I think I didn't do this one. Okay. All right. Watch this. There are totally 7 defects out of 200 opportunity. Okay. That will give you a DPO of 0.035. So this, how you would have calculated? 7 divided by 200. 7 is the total number of defect. 200 is the total number of opportunity. Keep it in mind, here we are not discussing any units. We are only discussing number of defects you produce, number of opportunities. This number of 200 opportunity could be coming from 50 units or 30 units or 55 units. That depends. Okay. So therefore, DPO is 0.035. Okay, that's a DPO. Now DPMO equals to DPO multiplied by 1 million. Okay. So in this case, it's going to be 0.035 times, okay, 1 million will give you 35,000 defects. Okay, 35,000 defects. All right. Okay. So what do we mean by 35,000 defect? Okay. If I achieve 35,000 defect, what is my sigma level? Am I operating in 1 sigma or 2 sigma or 1.2 sigma or 2.3 sigma? There is a chart available for it. This is called Six Sigma conversion table. Okay. Can someone tell me if the number of defects are, if defects per million opportunity is 35,000, what is your sigma level? Approximately. It doesn't need to be perfect. Approximately. $35,000, right? See, where is the 35,000? Here is a DPO. Here is a DPO. Look, where is 35,000? Where is 35,000? 35. Here it is. Okay. So 35,900 is 3.3 sigma. 3.3 sigma. If you go to 3.4, it's jumping to 28,700. Jumping as in reducing. Number of defects reduces to 28. So there's a big gap. You see, even with 0.1 sigma, look at the amount of improvement you're making. Huge improvement, isn't it? So you are operating somewhere around 3.3 some value. Okay, 3.38 or 3.37. So it's okay to say 3.3. Yeah, nobody's going to sue you because of this basic information. Okay, you're operating at 3.3 sigma. All right. We can get exact value for a, it is possible using another method called Z sigma method. We will not have time to go into that level of detail. It takes a lot of time. All right, I think this is enough. Okay, you get an approximation here. You're operating around 3.3 sigma. Okay, and what's your yield? If you're operating at 3.3 sigma, your yield is 96.4. Okay. All right, any question? Is it okay? Can we move to the next step? All right, I would like to just take an eye on the time. What is the time? Because it's close to 1.5 hours is gone. Yeah. All right. So what we discussed so far was mainly using the term defect, isn't it? Defect per unit, defect per opportunity, defect per million opportunity, even rolled throughput yield. We calculated how many input and how many output, how many of them are defects. Okay. So everything is based on defect. Okay. Where what we do, we are counting the number of defects. Okay. Now, what if we are not counting it, we are measuring it, okay, using specification limits, right? We are measuring using specification limits, right? So now we are talking about capability study using variable data, okay, using variable data. The moment we talk about variable data, then we will have something called as lower specification limits and upper specification limits, lower specification, upper specification limit, okay? All right, for example, let's say you make water bottle, and the water bottle capacity is, let's say, 500 ml. Water bottle capacity is 500 ml. Okay, that's what you are labeling on the bottle. Your capacity is 500 ml. Now, can someone tell me what can be the upper specification limit? What can be the lower specification limit in the chat? For a 500 ml water bottle, what can be the upper, what can be the lower spec? Why many of you are typing 0 in the lower specification limit? Imagine you go to a shop to buy a water bottle and it's an empty bottle. Would you buy it? Would you buy an empty water bottle with a 0 water in it? So lower specification, upper specification, basically we're talking about when you complete making the water bottle, when you complete filling the water bottle, okay, what kind of specification you try to achieve? What's the lowest specification you're trying to achieve, and what is the upper specification you're trying to achieve? That's my question. Okay, let's go one by one. All right, let's talk about lower specification. If you're promising 500, if the bottle is 500 ml bottle, what can be the lower spec? Okay, now some of you are saying 495. Good, 495. Yeah, 480, 499, 495. Fine. I would say in this scenario, my lower spec will be 500 ml. Why? Because I don't want to go less than 500, because that is what I'm promising to the customer. That is what I'm labeling it, which means technically, if someone measures the bottle, the liquid in the bottle, and if it's 490, they can legally sue you, because you are committing 500 ml there. How can you give 490 ml? You cannot. So 500 is a lower spec. Got it? So what about the upper spec? What is the maximum limit you would like to give? Okay, depends. That depends on your water bottle capacity also. Let's say, for example, 505 ml. I really don't want to go to more than 505 ml, because might be the water bottle capacity will breach, it might have leakage, the cap might not close properly, there will not be enough space for the temperature to the gas to release, so there could be issue. So my lower spec is 500, my upper spec is 505. Okay, and cost, yes, as you said rightly, cost will increase. All right, now, so lower spec is 500, upper spec is 505. Okay, so obviously by looking at these two examples, what you see here, let's call it A and B. A is more capable than B, isn't it? A is more capable than B, isn't it? It's very obvious, right? Just by looking at it, we know A is more capable than B. Why? Because if you notice here, you're producing many bottles here out of specification. So these are all your defects out of specifications. Now it might not look more here, but a bottling company which produces 1 million water bottle in a week or in a month, this could be running into thousands. We don't want that. We want everything to be as tight as possible. Again, remember the very first slide we saw, like few slides before. This is narrower, this is wider. We don't want this, we want this. Okay. You can use capability analysis to determine whether a process is capable of producing outputs that meets customer requirements when the process is in statistical control. Okay, what do you mean by the process in statistical control? We'll talk about it. Okay. Now, does all product have upper spec and lower spec? Can some product have only lower spec or only upper spec? It can. It can. For example, look at this example. This example has only upper spec. Look at the example. A call center where calls must be answered within 30 seconds. Within 30 seconds. Here we have only upper specification. We don't have a lower specification because 0 is better. Customer will love it as soon as they call. You pick up the phone and answer them, isn't it? So here you have only the upper spec. You don't have a lower spec because lower spec can be 0. Yeah, like Domino's Pizza. Yes, Domino's Pizza. Let me put in simple words. Any process, any services, anything which depends on time, like time, the amount of time it takes to complete a process, the amount of time it takes to disperse the loan, the amount of time it takes to answer a phone call, the amount of time it takes to attend a patient, the amount of time it takes to release the blood report or X-ray. Everywhere there is no need for lower specification. We are only working towards the upper specification. All right. Okay. Similarly, some production processes, some areas can have only lower spec. There is no upper spec. Like an example, a chemical company requires an inert gas to be at least 80% pure. All right. And you don't need to put the upper spec because anything above 80 is good for you. In fact, more the better for you. If the purity is 85, good, 88, good, 90, good, 100, good, fair enough, right? I don't care about the upper spec, but I care about the lower spec. The minimum it should be is 80, isn't it? And upper spec and lower spec, certain items, like for example, if you take a nut or if you take a ball bearing, it will have both lower spec and upper spec because it cannot be too small or it cannot be too big. It has to come within the specification, isn't it? Yeah. So in those cases, you have both upper spec and lower spec. Okay. If you notice here, this is a nutshell. This is like a graphical overview or understanding of how the whole thing, works. Okay. So if you look here, this is a process. Hold on, sorry. This is a process, right? Remember, process will have inputs and it performs certain steps and it produces outputs. Okay, inputs are x1, x2, x3, x4. Outputs are y. Okay, remember the function y equals to the function of x. Right? The output, okay, will be measured. The measurement will be called as data. Okay, in this case, we're talking about variable data. You see decimal places here, variable data. Right? Now the outputs will be measured. Okay, and generally we create something called as control charts. Control chart will have a lower control limit, upper control limit. Now control chart is a big topic. It's a 5 days training by itself. I will not be going into detail, but control chart is basically, it's a measure of voice of the process, what your process is doing. Okay. Control chart tells you what your process is doing. How is it performing, right? It is called voice of the process. Okay. And you start plotting the values in this x-axis, y-axis the frequency. So when you start plotting, stacking up for each unit the measurement, so you have a curve like this. Okay, this curve is your voice of the process. Okay, now what you're going to do now is you're going to match or try to align the voice of the process with the voice of the customer, what the customer wants, or what the manufacturing company wants, or what the service provider wants, what they want. What they want is the specification limit. What they want, what the customer want is called specification limit. What the process can do, is control limit. Are you guys understanding what I'm saying? What the customer want is the specification limit. What the process can do is control limit. Okay. Do you understand what I'm saying? Yeah, specification limit can also be called as tolerance limit. Specification limit can also be called as tolerance limit. Okay. Yeah, can someone tell to Mr. Muhammad that the audio is fine? Maybe he has to go out and come in, yeah? All right, so watch this. So this is what your process is producing, output, okay? So if you notice here, my specification, what I want is this line. Okay, let me clear this slide. Let me clear this, okay. What I want, my specification lines are here. You see, like if I continue the line here, and if I continue the line here, this is what I want. And this is what we are doing. So clearly, as you notice here, okay, certain units are going outside the specification limit. When it goes outside the specification limit, we're talking about non-conformances, right? Defects. Okay, errors, right? So what we need to do here, or I should not use here, what we should do here, so that we can come within the specification. Reduce limits. Yeah, Six Sigma project, yeah. Isn't it obvious? Sharif is asking. Yeah, that's what we are doing today. So let's do the Six Sigma project. Yeah, that's a good answer. But I'm expecting a different answer. So draw a line here, draw a line here. It's not a straight line, but so what we need to do here, what is the problem? What is the problem here? Can someone tell me what is the problem here? It's clearly not coming within the specification. Yes. What is the problem here? Exactly. Yeah, we have high variations. Our variations are too much, more variations. So what we need to do is we need to control the variations. We need to control the variations. When you control the variation, what will happen is it will fit within the specification limit. Yeah, it will fit within the specification. Keep in mind, we don't just want to fit. We want to fit very tightly inside. We don't just want to fit. We want to fit very tightly inside. Okay. All right. Okay, I already explained this, but let me talk about it one more time. Control limits are calculated from the process data. In other words, if you want to prepare a control limits, you need to start the process, start the production, measure the values, then only you can plot the control limits, then only you can plot the control chart. But specification limits are defined by the customer even before you start the process. Okay, even before you start the process. Specification limits and control limits are used for different purpose. This is a very important paragraph. Specification limits and control limits are used for different purposes. Control limits let you assess whether the process is stable, whether you're performing the processes with little variations or too much variations. For example, if you take a control chart and when start measuring, plotting the data values, what it tries to say is whether these variations are stable or unstable. If any point goes outside the control limit, we say the process is out of control. It is not stable. Okay, so control chart is a measure or is a tool used to study the process stability. Okay, is the process stable, is within control or not? Okay, while specification limits are used to assess whether the process is capable to meet the customer requirements or not. Okay, yeah, that's the difference between specification limits and control limits. Control limits are used in control charts, while specification limits are used to assess the capability of the process by using formula, and that is what we are going to do. Okay, we are going to assess the capability of the process by using a formula called CPK. Let me do that. Okay, yeah. Now keep it in mind, before I assess the capability of the process using the formula, CPK formula, first I need to assess whether the process is stable or not. Only a stable process I will use it to study the capability. If the process is not stable, I will not use the capability. What do I mean by that? If the process is going through a lot of variations, okay, there is no point in me to take the data from this process and check its capability, because the process is going with so much variation. Whatever capability I have this week, I might not have it next week, because it goes through so much variation, right? The capability what I have achieved this week, there is no guarantee that it will be achieved next week. So the first rule is we need to make sure the process is in control, whether good or bad, whether you're producing the product outside the specification, inside the specification, that's a different story. What we need to make sure is, are we producing in the same way for a long period of time? Then only we can check the capability of the process. Okay. Well, I know it is too much to digest at the tail end of the webinar, but I hope most of you understood what I'm trying to say. Got it? Okay, so before you want to check the capability, is my process capable or not to achieve customer specification, to achieve Six Sigma, first I need to check whether my process is stable. Because if the process is not stable, each week it is going to give you different values. For example, this week you achieve Six Sigma, next week you achieve 3 Sigma. Well, that is something absolutely wrong, isn't it? Yeah, it cannot be that, which means you are fluctuating too much. It is too yearly to determine, hey, what is my process capability? Because your process capability cannot be measured until your process is stable. Got it? Okay, all right, let's move on. It's already 7:40. I'm sorry, guys. Let me wind up a little faster, so I will have some time to answer some of your question. Yeah, I understood, Vignesh, but I'm running for the time here. I can give many examples, but I have more slides left. Let me quickly go through it. For example, what's happening here? This is the lower spec. Okay, hold on. This is your lower spec. This is your upper spec. Okay, yeah. If your performance is here right now, if you perform, this is your current performance. Okay, what you have to do is you have to shift the mean. Your average should be shifted. That is called shift the mean, right? Now watch this. Usually it is an easy option, easy to do, easy to achieve, because there might be something you're doing it wrong. Once you fix it, you completely come here. Okay, right? Now watch this. Here what is happening is, let's say green is the current one. Okay, green is the current one. You are all over here. Okay, here what we try to do, we are okay, our average is fine. The problem is the variation is too much. Here what we have to do is we have to reduce the variation. Okay, reducing variation is not so easy. Moving the mean is easy, but reducing the variation is not easy. Trying to do both, trying to shift both the mean as well as reducing the variation is usually happens in Six Sigma project. Okay, this usually does happens in Six Sigma projects. Okay, Ajay is asking, can we have the balance session part tomorrow? We're going to have the session till the 8 o'clock in UAE and 9:30 in India. right? Then we'll talk about it. We're going to have a lot of webinars. We are going to do webinars on a weekly basis because most of the people are bored, are sitting at home, not much to do. You know, they're looking for some kind of opportunity. So we are doing this. All right. So that's it. Just only one more formula. I'm done. Okay. So when you do the process study, process capability study, how about data collection? How long or how far we should collect the data? Data can be collected over a period of short term or for a long term. Short terms are usually within a week, within a day, within a shift, right? Usually 30 to 50 data point is enough. Yeah. But if you're going to do it for a long period of time, okay, which is better, but not always possible, then we're talking about at least 100 to 200 data point sample you have to collect and we need to process it in the formula. Okay. All right. So this is the one I was talking about. For example, this could be January, this could be February, this could be March, this could be April. So what's happening is here you collected 50 samples, here you collected 50 samples, 50 samples, 50 samples. As you see here, this is your target value. You are drifting all over the place. You see here, you're here. So this is called short-term variations, right? But over a period of time, if you take all of them, your lowest point is here, your highest point is here, isn't it? So, which means all the variation happens here. So when you combine all of them, you get the long-term variations. And for this very reason, guys, hold on, let me clear this. For this very reason, when I measure the my sigma here, I might achieve 6 sigma. No, this is not a great example of sigma. I might achieve 4 sigma here. I may achieve 5 sigma here. I might achieve 4.5 sigma here. I might achieve, for example, 3 sigma here. Understand? Okay. So for example, I achieved a 6 sigma here. In the month of April, I have achieved a 6 sigma. There is no guarantee that 6 sigma is going to continue, isn't it? Maybe in the month of June, I might go back to 3 sigma, or 4 sigma, or 3.5 sigma. Understand? So that is why whenever you measure the 6 sigma, your sigma capability, even though you achieve 6 sigma in a short term, we will say in a long term, we can possibly drift. So we might be able to achieve only 4.5 sigma. This is the reason why, even though you achieve 6 sigma, actually you were disclosing only 3.4, which belongs to 4.5. But in reality, you might have achieved 2 out of a billion. But what we're disclosing is 3.4 defects per million. So this 1.5 room for error is because of this reason. Yeah. Okay. There are many formulas available: CP, CPK, PP, PPK. These two formulas is for short term. These two formulas is for long term, right? Usually we don't do long term, but if you want, you can do. We do short term because we collect the data, we try to measure. Okay. And CP has a lot of issues. We will not do the CP. I will keep a separate webinar only for CP, CPK, PP, PPK with a lot of examples. Okay. Now I'm trying to explain so many things in a single webinar. It could be overwhelming. Let's do the CPK now. All right. CPK has a special formula, and the formula goes like minimum of upper specification limit minus your average, then average minus lower specification limit divided by 3 sigma. Okay. So we have to calculate this, and we should take the minimum of these two. All right. Watch this. Your normally distributed process has a mean of 28.5. You're producing some, let's say, some cookie, some biscuits, some cookie, right? And you collected samples from, let's say, 500 cookies over a period of a week or 1 day production, whatever. And you found that the average cookie weight is 28.5 grams. And you calculate the standard deviation to be 2.4. That's a formula to calculate the standard deviation, 2.4. And your lower spec and upper specification limit are given as lower specification is 19, upper specification is 39. If this is a situation, this is a scenario, what is a CPK? All right, look at the formula here. Minimum of upper specification is 39 minus the average. Lower specification is 19. Here is the average divided by 3 times the standard deviation, which is 2.4. So when you do the math, this and this is coming. This is lower. So we're going to take this. Okay. And the CPK value is 1.32. Okay, if my CPK is 1.32, what does it mean? Remember, when my DPMO is 35,000, what does it mean? It means I'm operating at 3.3 sigma. Remember? Similarly, if my CPK is 1.32, what does it mean? Again, we have a table. I'll come back to this. Again, we have a table, right? What is my CPK? 1.32. Where is 1.32 CPK? Watch the CPK here. 1.3, 1.33. So 1.32 is somewhere here, right? Which means I'm operating at how many sigma? 4 sigma. I'm operating at 4 sigma. This is called CPK conversion table. What we saw before was DPMO conversion table. This is CPK conversion table. So there are tables available for it. Okay. So if you're operating at 1.33 CPK, right? Okay. Your sigma level is 4 sigma. And if you want to convert that into parts per million or defects per million, it will be only 63. So you're producing only 63 defects out of a million. Okay. Right. Abhishek is asking what's the sample size for CP and PP. I just told you the sample size is 30 to 50 for CP, CPK, and around 200 for PP, PPK. But there is no rule. There is no standard available for it. It's just a matter of different gurus, different statisticians will come up with their own way of doing it. Okay. All right. So the recommendation for an existing process, if the process already exists, the recommendation is 1.33. If it's a new process you're designing, it is 1.50. If the process is a safety related critical process, then 1.5 for an existing process, 1.67 for a new process. These are all the recommendations. Again, no standard says about it. Okay. CPK means process capability index. Right. Watch this, short-term sigma, long-term sigma. Now, if your CPK is 2, your sigma is 6. Remember what I said, sigma means the possibility per million non-conformance is 0.002, which is 2 per billion, right? Yeah. But even though we achieve 6 sigma in a short term, we disclose 6 sigma in a long term, which is 3.4, which accounts for 1.5 sigma shift, or this is basically 4.5 sigma. Okay. Now, I know that CP, CPK, PP, PPK is a big topic. I just want to give an introduction to it. I will do a separate webinar on CP, CPK, PP, PPK. There is something also called as a CPM. It is by itself a huge topic, upper spec, lower spec, and all these things. All right. Okay. So if you want to become certified, there are different levels of 6 sigmas available. For example, yellow belt, green belt, black belt, master black belt. I personally recommend no other certification body other than ASQ. They are the leading certification body, but there are many available in the market. But the best one is ASQ, American Society for Quality. And for different belt, the requirements are different. Usually any general work experience is enough. If you want to become yellow belt, green belt, general work experience is enough. But if you want to become black belt, you should have worked in a 6 sigma project. You should have experience working in a 6 sigma project. If not, recommendation is to do the green belt, then do a 6 sigma project, then do the black belt. Master black belt is for full-time professionals. They should have done at least 10 6 sigma projects. This is for full-time professionals. But black is good, but before you go to black, you start with the green, right? Usually 3-4 years of experience is enough. General work experience is enough, nothing specific. In my training, I have dentists, doctors sitting there in my class because they own a clinic. Black belt means you should complete 1 6 sigma project. Now keep it in mind, 6 sigma project is not too, elaborate, too long. Usually 6 sigma projects, depending on the size of the process you're selecting. If a doctor who owns a clinic tries to reduce the patient waiting time for a small clinic, he might be able to do the complete 6 sigma project in a matter of a week or 10 days, right? That's enough for him to have 1 6 sigma project experience. You can apply for a black belt. Okay, yellow belt and green belt. Yellow belt is usually with no experience at all, fresh out of a college. If you're a fresh out of a college, university, you go with the yellow belt. Green belt is for people who have at least 3 years of work experience. Okay, 6 sigma will help in human resources in many ways. Okay, hiring time, recruitment time. Okay, any process you do, yeah, payroll process, on-time payroll process, on-time many places we can use human resources. Okay, now I'm gonna stop here, okay, and try to answer some of your question. Can we go, please ask the question in the Q&A box. Okay, can we do directly green belt with having experience? Yes, you don't have to go through step by step. Even you can go directly to black or master black, but usually it is difficult to find people with Six Sigma experience. So the best thing is start with the green, then move to black. Okay, training wise, almost the same in all the 3 levels. The only difference between green and black and master black is statistics. The movement when you move up, when you go to black and master black belt, there will be more questions on statistics in the exam, but fundamental principles, everything will remain same. Okay, guys, please ask the question on the what do you call Q&A. Okay, first question. What is the difference between DMAC and DMADV? DMAC stands for define, measure, analyze. Look at the last two letters are changing. IC stands for improve and control. DV stands for design, verify. In simple words, DMAC is for an existing process. You already have a process which you try to improve it. There you do the DMAC. If you want to design a new process with Six Sigma capability, that is DMADV, where D stands for design and V stands for verify. Okay, where the other one is improve and control, which the moment you use the word improve means what? You're improving something which already exists. Okay, all right. So I'm done with this. Please ask the question on the Q&A, not the chat. All right. Next question. What's the difference between Kaizen? Kaizen is a Japanese term which means continuous improvement, improve for good. So it's a continuous improvement. It's a long-term initiative. Okay, you'll never stop continually improving, isn't it? While Six Sigma and DMAC are breakthrough improvement. That's a key difference. Kaizen is a continuous small incremental improvement, while Six Sigma is a breakthrough improvement in a matter of 1 week, 10 days, 30 days, 60 days, right? Where you bring your performance to an extreme high level. Whereas Kaizen, you do it slowly. I believe I answered this question. I also answered this question. How is the Six Sigma applicable in engineering operation maintenance, even more in first? As I said, and it applies in engineering, as you know, it was originally introduced in Motorola, which is an engineering company, right? Electronics and engineering. So it started in Motorola, then it moved to General Electric, Honeywell. Most of the top engineering companies, they use Six Sigma. Okay. Somebody is asking how to calculate cost of poor quality. Cost of poor quality is calculated by adding cost of internal failure cost and external failure cost. To do the proper calculation of cost of poor quality, your accounting system should be different. Most of the accounting system does not support calculating the cost of poor quality. To support cost of poor quality, your accounting system should use activity-based costing method, ABC method. If they use the ABC method, then we can able to do it properly. I think someone copied all the question and pasted here. Let me answer this. Which type of industry can apply the Six Sigma concept in its best? As I said, any industry. Okay. Is RBT applicable in Six Sigma? I don't know what RBT here you meant by, so I'm going to skip it. Sixth question I answer. For all the process failure issue, do we use Six Sigma or not? Now listen, Six Sigma is used whenever we have a lot of data in place, whenever the process is critical and whenever we want to improve it. See, sometimes you know what is the root cause of the problem. Keep in mind, this is very important. When you know what is the root cause of the problem, all right, you don't need Six Sigma project. You directly go and fix the problem. We use Six Sigma project when we don't know what is the root cause of the problem, or there are too many variability. So we want to find, we need to define, measure, we need to analyze. Yeah, we need to use a lot of data to do that. How to calculate COP, I already explained. Relationship between control limit and specification limit, I think I already explained to you, right? Control limit is what your process is doing, Is it stable or not? It is used to measure the stability of the process, where specification limit is used to check if the production or the product or the unit what you're making is meeting the customer specification or not. Ideally, your control limit should come inside your specification limit. Okay, inside your specification limit. All right. Next question: how to find the real process variation root causes? Yeah, that's a training, right? That's what we will teach you. That's what we're going to do in analyze and measure and so on. What time requires to certify a Six Sigma Green Belt? Six Sigma Green Belt is usually a 30 hours training program. In fact, we are starting one online training program, I think on April 10, I think Friday. Yeah, 6 hours per Friday for 5 Fridays, where we will take you very close to passing the exam. Then you take an international exam. Once you pass it, then you will achieve it. Six Sigma applicable for mass production only? No. As I said, it can be applied even for a small clinic. Yeah, wherever there is a process, wherever you want to make improvements, you can apply Six Sigma. Okay. How are samples picked for CP and PP or CPK or PPK? Samples are picked in very different ways. You can do proper statistical sampling method, where you use formulas, calculate the sample size, or samples can be selected based on judgmental or convenient. There are many methods are there. What you're talking about is sample selection. Sample selection is a big topic. There is random sampling, non-random sampling. In random, we have clustered, stratified. There are different topics are there. In non-random, we have convenient sampling, judgmental sampling. Again, big topic. Okay. How do we get certified through ASQ? What happens is we give you the training, then you have to apply for the exam. We will help you to apply for the exam. Once you sit in the exam and pass the exam, you become certified. Okay. Exams are conducted throughout the world, right? In all major cities. I think I answered most of the question. ISO 13485, maybe. Okay, this is a good question. What is the difference between Lean Six Sigma and Six Sigma? See, Lean is a very fancy term people are using. Six Sigma itself is, Lean is included, but yeah, some people say differently. Watch this. What Six Sigma focuses on? Reducing variations, right? Eliminating defects. That is a focus on Six Sigma, right? What is Lean Six Sigma? What does the word lean means? Lean means elimination of waste. Elimination of waste. Six Sigma focus on elimination of defects. Lean Six Sigma focuses on elimination of defects as well as elimination of waste. Now, what is a waste, right? Defects are waste, right? Excessive waiting time are waste. Reworks are waste. Repairs are waste, right? So there are many different types of wastes available, right? Are there. So Lean Six Sigma focuses on achieving Six Sigma in the most efficient manner, right? Most efficient manner with minimum input and maximum output. Okay. Any other question? Will you give us a copy of the slide? No, we will give you the video, not the slide, because we don't want to use this slide in your internal training. Yeah, Riham, that's the idea. Okay. Any other questions? Okay, let me look at the chat. Can we use FMEA? Yes, you can use FMEA. FMEA is one of the tool used in Six Sigma. Six Sigma used many tools. Can I sit directly to Master Black Belt? Yes, Dr. Slime, you can if you have 10 Six Sigma project experience with you. Okay, keep in mind, all Six Sigma are projects. It has a start date, it has an end date. By end date, you should improve your process performance. While Kaizen and PDCA doesn't have any end date, it's a continuous improvement. That's why Six Sigma is a breakthrough improvement. Some questions are big questions, guys. I cannot answer. Somebody's asking, can you please walk us through data collection planning? It's a big topic, yeah. What is the purpose of PPK? PPK is for long term. When you collect the data for a long period of time, use PPK. See, formula is exactly the same, CPK and PPK. The only difference is CPK is short-term data collection, PPK is long-term data collection. That's it, nothing else. Okay, guys, see, I answered many questions. And We are still on time. Let's look at some of the good questions and try to answer. Difference between quality circle and Six Sigma project. A quality circle can initiate a Six Sigma project. Okay, a quality circle, which is basically a group of people. Yeah, they can initiate a Six Sigma project. Next question. Do we need to check normality of a process before we calculate capability? Absolutely, yes. We need to check the normality. What if the data is not normal? Then also we can do, there are other formulas available. You have to check for normality. If it is normal, then there are formulas. If it is non-normal, then there are other formulas. Okay. Difference between CPK, PPK already explained. Or just-in-time and Six Sigma are similar? Absolutely not. Just-in-time focuses on reduction of inventory, 0% inventory. It's a different technique altogether. And just-in-time is something followed in the supply chain for the entire production floor. While Six Sigma, as I said, is a process-based approach. Will you send the video recording study material? Yes, we will send the video recording, which has the slide. So watch it. Any connection between Six Sigma and a worker welfare standard? Absolutely not. I'm having experience of 7 years. Can I try for green belt? Yes, of course you can. How can we get the webinar recording session? Tomorrow you all will get an email from us, which will have the recording link. You can play, you can watch the recording. Any plan for advanced level of webinar? We will try, sir, because what happens is not many people have advanced knowledge. It creates a lot of, difficulty in delivering a webinar for advanced topics. We will try. Okay. All right. I think that's enough. I'm just going to ask you a couple of more questions, if you don't mind. Can you please answer this question, please, if you don't mind? There are no questions coming up, guys. There are no poll questions coming up. Okay, let me try one more time. Wait, maybe some issue. What about now? Can you able to see the question now? Yep. Yep. I just want to know what is your interest? Okay, someone was asking what is the difference between ARMI and RACI. It has it is project management tools and technique. Basically, it's a matrix we use to assign roles and responsibilities to the team members. Yeah. Well, ARMI stands for different letters. A stands for approver, R stands for resource, I stands for interest, M as a member. While RACI, R stands for responsible, A stands for accountable. It's basically an assignment of role and responsibility to your project team members. So we know who needs, who does what in your project. Okay, in our factory, we manufacture gears and we have defects like dents on the gears. Can we use a Six Sigma methodology to solve this problem? Yes. If you already know, if you already don't know, if you already don't know what is causing this, see, if you already know what is causing this problem, you identify the problem, which could, for example, you changing the die is old, the die has the wrong specification. If you already know the problem, it's not a Six Sigma. Yeah, only if you don't know the problem, right, then you go into Six Sigma. What is good to go? Lean Six Sigma or Green Six Sigma? Oh my God, this terminology is Green Six Sigma. Yeah. See, guys, Six Sigma includes lean already. For example, if you take ASQ, American Society for Quality, there are 3 chapters completely for lean dedicated within the Six Sigma. See, there are new certification bodies coming up like ISAAC and IQC. There are many certification bodies. They cannot compete with the ASQ. ASQ is a very powerful body. So what they do is to differentiate themselves, they're adding all these fancy terms, green and lean and whatnot. Yeah, Six Sigma is Six Sigma. If we want to achieve high precision, high output with the least resources, so that is fine. What is the type of data called? Yes or no, okay, not okay? Yeah, that's an attribute data. And if you want very advanced technical answer, it is called binomial distribution. Yeah, where the result are either yes or no. Okay. Six Sigma is not controlled by anybody. Six Sigma is an open knowledge. There are different certification bodies offers and accredits you that you have the knowledge. ASQ is a good one. But you said attribute data is number. Counting is number, isn't it, sir? For example, you are checking 10 light bulbs. Okay, you're checking 10 light bulbs, right? To see how many of them are working, how many of them are not working. If 6 of them are working and 4 of them are not working, 6 is a number which tells you 6 units are working, 4 units are not working. So obviously it is going to be a number. Okay. Is there any disadvantage for Six Sigma? Well, like in any model, if you do it properly, I don't see any disadvantage. Can we brief what is ARMI and RS? I just explained to you that one, right? Is threefold as an authorized agency of for ASQ? No, just because I'm promoting ASQ, you see, that doesn't mean we are an authorized agents of ASQ. We are not. We were for 3 years, then we stopped it. But we are still doing the training because exam is anyway, you have to do it in third party, like PMI. Who is giving the Six Sigma belts? ASQ. ASQ is one of the body which gives Six Sigma belt. Other than ASQ, there is something called ISAAC, International Six Sigma, so something ISSAC. Then there is something called IQF. There are different bodies are there, but the best one is ASQ. It's more than 100 years old, so you could imagine. Yeah. Okay. Can we discuss the application of Six Sigma in facility management? Now, facility management is a big topic, sir. In facility management, tell a process, any process. Okay. In facilities, we do many processes, right? Pick some processes where we can able to apply Six Sigma. No, issues is not a, no, what is issues? Issues is not a process, right? Issue, what is the issue? In which process you're facing the issue? All right. So I got all the, result for the next webinar. Okay. That's all from me, guys. I'm just leave you guys with one more question just for the rating of this webinar. So we'd like you to rate this webinar. Yeah, first 5 minutes, 10 minutes, we have the technical issue. Leave the technical issue. Other than the technical issue, how you feel the webinar is. Try to give the rating before you leave, please. Okay. I'll try to give answers for some of the question while you give the rating. Which one is better, Six Sigma or CMQ? Which is better for career growth? Now, Six Sigma is a process by process quality improvement approach, right? So it talks about a process and how to improve it by using specific tools and techniques. While CMQ is a managerial level and it is a leadership level. So if you're working as a senior manager or department manager or want to become manager, CMQ is more suitable for you because CMQ is certified manager of quality and organizational excellence. It has topics like leadership, training and development, supply chain management, customer management, quality tools and techniques, general management. So it has topics which helps you to become a good manager, which helps you to lead the organization. While Six Sigma is a problem solving quality improvement tool, specific. Okay, polling is not working. Okay, wait. Let me give the polling one more time. I don't know why the polling is not working. Vignesh, when will be the next session? Most likely next week, Vignesh. Again, you cannot see the survey poll. Nobody's responding, so I guess you cannot see. Let me relaunch it.